Hello and welcome to this extended Euclid's algorithms extension. Like in our part 8 video, we introduced extended Euclid's algorithm. We will do some more problems to get accustomed with the process. So we treat this as an extension of our part 8 video. Now come on, let's get started. The problem is to find the GCD of the numbers 1, 5, 7, 5 and 2, 3, 1 by Euclid's algorithm and express the GCD of the two numbers as a linear combination of m and n. So my target is to find the linear combination of this 1575 and 231 at last. To begin with, I need the GCD, for which I begin with Euclid's algorithm. Euclid's algorithm, we begin with A, the biggest number, B, the smallest number. So out of the two numbers, 1, 5, 7, 5 is bigger and 2, 3, 1 is smaller. So Q, the quotient when A is divided by B, and R, the remainder when this is going to be divided by 231. Now 231 goes in 1575 6 times and it leaves a remainder of 189. Next, this being non-zero, the algorithm gets executed by replacing the value of A with B and B with R. So 231 enters here and 189 enters here. Now divide 231 by 189. How many times this goes? This goes only one time, and 231 minus 189 leaves a remainder of 42. This being non-zero, again you repeat the algorithm. B enters A, R enters B. So 189 is now divided by 42. How many times 189 goes in 42? It goes 4 times and leaves us with a remainder of 21. So now repeat the next step. Again the algorithm goes on as the remainder is going to be non-zero. Replace A with B, so 42 enters here. Replace your B with R, so 21 enters here. Divide 42 by 21. How many times this goes? It goes 2 times exactly and leaves no remainder. So we have reached the end of the algorithm. So since we have a 0 remainder, we find that the value in the place B, 21, is going to be the GCD of the two elements. Or if you are finding this to be a little tough, you can just go the last non-zero remainder. Okay, so how do we go about it? The last non-zero remainder. Okay, remainder is going to be the value 21, and this 21 is becoming our GCD of the elements. What are they? 1575 and 231. Now the next process is, I need to express this 21 as 1575 times of a quantity called as m and 231 times of a quantity called as n. So for this purpose, what we will do is rewrite these values using the division algorithm, which is of the format A equal to BQ plus R. So let us now rewrite it. So A, which is 1575, can be replaced as 231 times of Q, which is going to be 6, plus R, 189. So the next number 231 will be replaced as 189 B times of Q, which is 1, plus the remainder 42. Next number A, 189, will be replaced as B, 42 times of Q, which is going to be 4, plus the remainder 21. And the last stage will be 42 can be replaced as a B, which is 21 times of 2 plus the remainder 0. So now we are going to make use of this quantity to retrace from the position 21 to our original values 1575 and 231, which is the starting point. Okay, so we will begin it again to find the linear combinations of our A and B. So how many steps we will be requiring? We start with 21, replace 42, replace 189. So 1, 2, 3 steps and the problem will be over. Okay, now start replacing the last value, which is going to be 21, by the quantity towards its left. So how can we replace this quantity as? So now what happens? This 21 will be replaced as, move everything to the left, 189 minus 42 times of 4. My step 1 is over. What is the next number to be replaced? Next number to be replaced is this 42, which is the remainder. Where is the 42? Here. This 42 has now to be replaced with. How do we replace this 42 with? Replace the 42 with the quantities by pushing it to the left. So what are the elements to the left? 42 will be replaced as 2, 3, 1. Bring this to the opposite side. So minus 189 times of 1. This is the expansion for 42 alone. What this has to be multiplied with? This has to be multiplied with 4. And you have a 189 in front. Let us take it with a factor of 1. So this becomes 189 times of 1 minus 231 minus 189 times of 1 multiplied by 4. Let us expand. 189 times of 1 minus 231 times of 1 into 4, mix it as 4, minus into minus plus, 189 times of 1 into 4 will be 4. Now let us club this 189 here. So it is 189 times of 4 plus 1, which is going to be 5, minus 231 times of 4. So now we are done with our step 2. What is our step 3? Replace the last value of the remainder. Which is the remainder? 189. Where is our remainder? Here is our remainder. So this 189 has to be replaced with what? The quantities towards its left. Okay, push everything to the left. So this 189 now becomes 1575 minus 231 times of 6. There has to be a quantity which is 5, which is going to be multiplied with it. Don't forget it, because the 189's expansion alone is this bracket. This bracket is being multiplied by 5, minus you have the extension of the second term, which is 231 times of 4. So now let us expand this as 1575 times of 5 minus 231 times of 5. 6 are 30 minus 231 times of 4. We are almost there. So this is going to be a 231. This is a 231. So let me replace this 1575 times of 5 minus 231 times of, this is going to be 30, and this is going to be 4. And hence we have 1575 times of 5 minus 231 times of 30 plus 4 makes it as 34. But the linear combination has a plus sign over here. So I need to be careful to push this minus sign inside so that I have the constant to be changed as minus 34. Now 21 is the quantity where we have replaced it of this format, identifying it with the required format A times m plus b times n. So what is the value of m? I now find that the value of m is nothing but 5 and the value of n is nothing but minus 34 for this problem. I hope you understood the steps. We will do one more problem to get ourselves clarified with. The second problem will be find the GCD of 1, 2, 3, 4, 5 and back return 5, 4, 3, 2, 1 and express the GCD as a linear combination of the given integers. The Euclid's algorithm part has already been explained in the previous video. Kindly go through it. We will begin with the division algorithm part. That is, we begin with the biggest of the number. What is the biggest number? 5, 4, 3, 2, 1. Now this division algorithm is A equal to B Q plus R. This 1, 2, 3, 4, 5. When this is going to divide this 5, 4, 3, 2, 1, it goes how many times? It goes 4 times, and now it leaves me with a remainder of 4, 9, 4, 1. So this is going to be my remainder. What is happening in the next stage? This B is now getting shifted to your A, 1, 2, 3, 4, 5, and this B will now be divided by this R, which is 4, 9, 4, 1. How many times this 4, 9, 4, 1 goes? In this 1, 2, 3, 4, 5, it goes 2 times, and it leaves you with a remainder of 2, 4, 6, 3. Now begin with the next step of the algorithm. As we have a non-zero remainder, push your B to A, so 4 9 4 1 is pushed over here. Push your R to B, so 2 4 6 3. So when I divide 4 9 4 1 by 2 4 6 3, how many times it goes? It goes 2 times and leaves you with a remainder of 15. So now this again being a non-zero, the algorithm gets repeated. So you take your B to be your A, 2 4 6 3, your R to be your B, which is going to be 15, and we check that 15 divides 2 4 6 3 how many times? 164 times, and leaves you with a remainder of 3. Again, this being non-zero, we repeat the process of the Euclid's algorithm by pushing your B to A, so this becomes 15, and pushing your R to your B part, so this becomes 3. When 15 divides 3, it goes 5 times, 5 3s are 15, leaving you with no remainder, which is going to be 0. So the algorithm stops over here. What is going to be the GCD? The last non-zero value, or the value of your B, is now your GCD. Therefore, we say that the GCD of 1 2 3 4 5 and 5 4 3 2 1 is going to be 3. Now I need to express this 3 as 1 2 3 4 times of some integer m, and 5 4 3 2 1 times of some other integer called as n. So how many steps we'll need? From 3, I backtracing, I need step 1, step 2, step 3. So in 3 steps we will be able to stop the process. So we will begin with 3. How to go about with this 3? This 3 can now be replaced with the push everything to the left. So I will have 2 4 6 3 minus 15 times of 164. Now, what is the next remainder to be replaced? 15. Where do you find this 15? Here. So now replace this 15 by the quantities towards its left. So what will this be replaced as? 15 will now be replaced as 4 9 4 1 minus, this goes to the opposite side, 2 4 6 3 times of 2. So this is the replacement for 15. So there is going to be a product of 164 to the side, so don't forget it. So we have 2 4 6 3 times of 1 in the front, and the remaining quantities over here. Now you can club your answers. 2 4 6 3 times of 1, expand, minus 4 9 4 1 times of 164, minus into minus, you will have it as plus 2 4 6 3 times of what you have over here is 164 multiplied by the quantity called as 2. This makes it as 328. Now club your 2 4 6 3 here and here. So it is 2 4 6 3 times of 1 plus 328 minus 4 9 4 1 times of 164. So this becomes 2 4 6 3 times of 329 minus 4 9 4 1 times of 164. Now we are done with our step 2. Now moving back one more stage. What is the next remainder to be replaced? 2 4 6 3. Where do we find it? We find it over here. And what is this to be replaced with? The quantity towards the left. What are the quantities towards the left? Move over here. Replace this with 1 2 3 4 5 minus 4 9 4 1 times of 2 multiplied by 329 minus the other factor over here left out is 4 9 4 1 times of 164. So now on expansion, 1 2 3 4 5 times of your 329 minus 4 9 4 1 times of, you have 329 multiplied by 2 to be equal to 658 minus 4 9 4 1 times of 164. Now there is 4941 and 4941. Let us club both the quantities. 1 2 3 4 5 times of 329 minus 4941 times of, this is minus, so it is 658 plus 164. So 658 plus 164 makes it as 822. So this becomes 822 times of 4941, and the quantity towards our first part is 329. The next step is also over, and now we move to the final stage. Move one more step back. What is the last remainder to be replaced? 4941. Where do we find it? Here is our 4941. How to replace it? By the quantities towards the left. Push all the quantities to the left. So how will this 4941 be replaced as? 5, 4, 3, 2, 1 minus 1, 2, 3, 4, 5 times of 4. So this is the replacement for 4941. This has to be multiplied with the quantity called as 822. So this is going to be that, don't forget it. Okay, so 1, 2, 3, 4, 5 multiplied by 329 minus the quantity. So let us expand. 1, 2, 3, 4, 5 times of 329 minus 5, 4, 3, 2, 1 times of, this multiplied by 822 is 822, minus of minus makes it as plus, 1, 2, 3, 4, 5 multiplied with 822 times of 4. So that makes it as 3288. Okay, so now we are almost there. Now last term to be clubbed is 1, 2, 3, 4, 5. Club your 329. This is the addition plus 3288. And the next term is 5, 4, 3, 2, 1 with 822. Now this now gives me 1, 2, 3, 4, 5. So when I add 3288 with my 329, the answer becomes 3617 minus 54321 with 822. We are last reached the stage of the linear combination. So my 3 has been expressed as 1, 2, 3, 4 times of m. This m is a direct format, but there has to be a plus sign over here, so that has to be adjusted. Push this minus sign to the opposite side, hence the value of m now takes it as 3617, and n with a minus sign getting in gets the value minus 822. I hope these two extended problems can give you more clear idea on how to proceed with an Euclid's algorithm, and then to proceed with a linear combination of the GCD of the given numbers. Please ping if you have any doubts in the comment section. We will try to get back to you at the earliest. Happy learning. Keep learning. Thank you.